gonna start that recording. So Petrina Lena, wow, that's a difficult name for me, is joined. But yeah, the mic symbol is not on yet, so Charles is joined. The name is joined.
Hello.
Hello. Just for your information, so this workshop we already started the recording now. So because some people are asking if we can record this and they can watch it later, for those who didn't make it. So I wonder, so if you guys are okay with that, so yeah, so we will find a way to try to get this access to the people in the group. So I was wondering if you guys have any issue with that.
Not from my side.
Okay, great. All right, we have 6 people now. So we're gonna just start it. This one, I think we can start it now. So why do you think?
Yes, sounds good.
Yeah. All right. So I was just actually I was thinking beforehand about how actually should we, organize or approach this workshop, and I was thinking maybe how do you call? So basically, those workshop, this exercise we had is basically we need to write some code and to do using this code to do some test, and we need to play with some parameters so that we get some like some result, and then you need to somehow connect it with your theory, which is learned by your like in the lecture, so that you can to show that. So basically, those report is gonna you need to in the report you need to like show you that you actually understand why this happened, and like you have to know it even you get not like very good result from everything you try, but you have to learn. But the more important thing is like you really need to understand what is going on and why it is. So that's basically my feelings. So yesterday I was actually talking to some people. Not yesterday, on Friday night there's a game night. I don't know if you guys went. And there are some people also complain that the lecture is not deep enough. I mean, it's like quite shallow. I mean those guys actually with the master of the mathematic background. So I think from those guys' opinion that this is yeah, I think this issue is quite. I think for those guys who are really good at mathematics and they come to this lecture and they're saying, okay, the lecture, the professor was saying it's not so for them. They like it's not deep enough. I mean, it's not. It's just like you are just touching a topic and you just touch the surface and it didn't go too very deep. And now we have to use it to do some exercises. So more people join. And all right. Okay. So the way actually I was thinking about how we're going to organize this is like maybe first we go can go through some question. Like if any one of you have any question, I mean, I was expecting like people may have question regarding how to, actually with the actual MATLAB code, like how do you achieve this, achieve that? That's one category. And another thing is like if it's more like Siri or report related. So if like for example, how do you choose these parameters or values, and how do you do such things like that, or someone is not clear with what the Siri is about, like what is so that anyone can just if if you think or even you think you just have some information about it, you can just jump after the question session, and you can just provide your information or start it. And I was think maybe it's a good way to someone can like kind of like help with like to just record those questions and record what is some summary of our answer, and we can just then maybe put it like in a Google Doc or something, and that you guys and then people later can find it quite useful. But yeah.
Indeed, that's good plan.
Yeah.
Have you managed to do the whole assignment actually?
For me, so let me share my screen for just the. I mean, the whole assignment. I'm not sure. I think I finished the code, like just the coding part. Like I can use my code just to run. Like to get the data that's which I needed for the report, but I haven't done like all the how do you say, like all the question, like because you need to run several algorithms, like learning algorithm, and
Yeah.
you need to get their data, and you need to analyze. But actually one of the questions I think most of people have is like, how did you actually evaluate? Because let's say, so that I have the this is our can you guys see my screen clearly?
Yeah, I can.
Yeah.
So let's maybe just start it with this exercise. Okay, let's just go through this. So here, let's see. So this exercise. So this one here, it's basically you are doing the function approximation, and you're giving this kind of like function, and then you try to use algorithm to but this one they already provided, so a template. So you basically, what you need to do is just to do some modifications in the code, and you just change whatever algorithm you are trying to compare. And also there's a noisy data here, so that's pretty much the same. You just need to change like a code here. So I have actually kind of organize my code here. Oh, this is I think that's not this one. Let me just open that code real quick. Documents, MATLAB, exercise 1, this algorithm 1. So for this one, it's actually quite straightforward. The functional approximation. So here you just whatever you need to do here, you just need to like change the training algorithm you are trying to compare with. Just do it, just compare them one by one, and then you have to and then you just here, and the second part of this learning from the noisy data generalization. And you just basically need to change like change this t to yn to from y. So that's basically, you just did it. And here it's saying that you need to, maybe for the noisy data, you want to add some more noisy data. So what you're gonna do here is just change this line. So originally, I think this one is 0.05. So you can change it like into smaller ratio so that you get, for example, I changed it to 0.01 so that you can get like 5 times of the original data size. So for this one, is running this is quite straightforward. So you get basically a graph and you get the linear regression compared to the original values. And then you get, yeah, I forgot to like check, sorry, figures. So let's take a look at the same size. If you open this with laptop, MATLAB, and guys, don't forget that, like, if you have any question, just shoot, and we will, you know, try to cover as much as possible. Because I mean, I'm not trying to say that maybe I was right, I was doing the whole thing right. So if you have any comments or suggestion, just feel free to shoot.
Yeah, but one thing here, just to go over those, I suppose the first function one. So basically, we're just using that script that they gave us.
Yeah.
Like just for the very first one now, the function approximation. We use that script. We changed the 2 different algorithms that are there in the first couple of lines, and then basically the set of figures that it outputs at the end. Yeah. This. So we're just comparing
this big figure. But I'm not sure if you just need to put the figure, maybe, I don't know, because we are only giving an limitation of 4 pages, and because I think it's more likely what you want to explain, you know, like it's like
yeah,
you
so
don't
we
have to just
kind of explain.
Yeah,
which
you don't have to use the whole
best.
everything of the pictures, but it's depending on what you can.
Yeah, I think we had to report the R values and also explain why we obtained it with a certain back propagation method. So linking it with the theory, I guess.
Yeah.
Oh yeah, that makes sense.
So this one, it's more like I think because I haven't really go through like all this algorithm, you know, like it's like when I have in the lecture, I was like, okay, that's an improvement, and I don't really know. I mean, I haven't really carefully studied the lecture yet, so I'm just here just to. For me, I'm just happy that I can get the result, and then later on when I restudy the theory, and then when we are making the report, then we know what is going on. Yeah. So for this part, I mean, just let's say now let's just from the coding part. And point of view, anyone still have issue with this first 2 part, like the functional approximation and with this noisy data? Anyone still have question? Because then we're gonna jump into the bigger one.
I just have a stupid question because I'm not really familiar with MATLAB, and with the pictures you were showing that I also had. I'm just trying, it's quite stupid, but and not really related to the thing, but to put the legend on the side, because sometimes you can't really see what's happening.
What do you mean? Like you want to put the legend like outside of the boxes?
Yeah.
I'm also not so familiar with the MATLAB. Actually, I'm not sure how did you do that. Anyone have a suggestion?
You can do it with, you can do it with when that figure window is open. Up in the top left, there's different options. So I think normally the hand is, or maybe it's the pointer is open. There's one of those. I can't remember if it's the hand or the pointer, and you need to click on the legend, and then you can move it basically.
Oh, great.
So there's a few options in the top left. You know, it's the other ones with like zoom and stuff like that as well. But up there, you can select each part of the graph and move it.
Okay, top.
When you're in MATLAB now, not in this.
Yeah, actually, something that I thought that was easy to write a report later on, it was also saving the figures. But before you save them, you can format them such that what you save, it's still quite interpretable. Because when you save it, for example, like it is, it becomes weird in the output. So if someone wants, I can put the code that I used for formatting in the chat box.
Mm-hmm.
Yeah, for sure that would be helpful.
I will
Yeah,
just put it there,
that's
and then I'm just looking for it where I had it. It's just a little small thing, but for example, I was planning to write the things later on, and just already trying to run it and understand it a little bit.
okay. So for that one, maybe yeah, we don't have to show it now. I mean, that's just more like decoration afterwards, and we can maybe later on we can have a have a look, and then it's then we can find a way to put this online or somewhere. I don't know, like for people whoever who wants to use it.
I knew.
All right. Okay, so
Can you hear me?
Yes, I can hear you.
And I run the same algorithm one, but I get different results.
So your problem is like you just run the same thing and you get different results. Like you just run the same code and then you get different results. That's what you're saying?
Yeah.
But how much is the difference? Because it can be possible that different training is you get like your result can be a little bit different. I don't know what is Yeah, you go ahead. Yeah.
Are you training with the algorithm 1 and algorithm 2? I mean, in the line 18 and 19, the chain GD and chain LM?
Well, that's just like the last running I was running actually, so it's not so maybe for this problem issue you need to really give us specific like configuration of the code, and then you show us a screenshot, and then we can see what is going on, because this is very general question actually. So I would, if you can provide more information, later on we can discuss in the group, and then we can answer your question.
Okay, so.
All right. So you can go on with that, and when you are prepare your information, then we can if we still have time tonight, then we can go discuss, or if we don't, then you just post it in the group, and just post it in the group, and then we can have a look at it. Okay.
Okay.
All right. So any more questions regarding to those two parts? All right, let's move on to the personal regression example then. Which is a major effort of this exercise, I would say. Okay. So for this one, you basically what you're gonna do is like you are getting this kind of like data set from them, from the and then you are just like you are building a new target data set using this formula, like so, and then you just need to. And then you need to, so you need to train a network which takes two input, which is X1 and X2. And then the data set, which is the target data set, is the one we are just creating this. And so the creating of this data set is quite straightforward. So you just like enter all your digit number here, and then based on your student ID, and then you just load this data set, and you just I just copy and paste these things and add some product operation between, so then you get your new training data. Okay, and then it asks you, okay, you need to build and train your forward neural network using your training sets and the validation set. And then, of course, you're gonna try different network algorithm, I think, from, check my code real quick. So, okay, let's just not jump too fast. So more like you need to build your training set and validation set. And test set, of course. And then it's like they're in this exercise, they are suggesting just 1,000 random samples from your data set. So basically, from the previous, I think there's a document which is discussed in the work in the exercise session, like with the TA. So they are suggesting using this random permutation, like random perm, to select to draw the random index for your data set, for training set. I mean, for all like training set validation and test. So you just draw 1,000 of them, 1,000 of them, and then in the range of the length of the one of your input set, which is, I think it's like 30,000 or something, 30,000 to 600. And then you just learn from that. Once you have the random index of your, once you have the array of the random index, then you just, directly like use the index and you just get your training set. And then you use this kind of like, and you just horizontally stack them together. Or, I mean, this is like the operation. So then you get your training set, and then the training set for your input, and this is the training set for your target. So basically, and then you need to print this. So we will get into this later. And then this is basically the same for the validation set and the test set. So basically, like these are just copy paste. Yeah. So
I'll add one
yes.
thing there. That random permutation, I think you could have the error where you select the same sample for your training set and your training set and your validation set, that you can get duplicates, which you don't want. So I think maybe you can change it a little bit, but
I think it does say independent, doesn't it? Independent samples.
I think
so it doesn't matter if they overlap.
No, but surely it has to be they're independent. The three sets are independent, no?
I thought independent, which means independently sampled, not independent as in they have to be disjoint of each other. I don't know.
Well, I jump into
sure. I was only kind of guessing from.
Wait, because people are actually. Maybe it's on the Google.
I mean, if by independent they mean the data to be disjoint, then yeah, you're correct. They have to be different. But by independent they mean independently sampled, then it's okay for them to have overlaps. So
yeah.
I'm just trying to find the original reference for this question because someone already asked the TA, I guess. And I'm just gonna switch. Okay, so how do you should select independent samples from your data? Exercise 1. When using the randy command, somebody using the randy command, it is possible to have the same value, right? Indeed. So here it's just saying it's just better to use random permutation. Notice that this is random permutation, like the array you get, they will not counting. Like in the, for example, this T index, it's not just gonna be they like the value itself, they will not appear, like they will not repeat. Like you cannot have like 1, 1, 2 or something like that. You just can have they can not repeat itself. So maybe we can run this one real quick. Yeah.
It was just from, I think it was from the module last year, the machine learning module last semester, that I thought that the training set and the validation set, for example, cannot contain the same samples. They need to contain different samples. Otherwise, you're training on something that you're going to use a test, or you're going to use a trained sample as a test, which doesn't make sense because it's been trained on that sample. I mean, maybe it's not important or whatever, but it's very easy to fix. That all you do is that first line there, T index, instead of putting 1,000, put 3,000, and then split your training up into the first 1,000 of it for the training samples, the second 1,000 for the validation, and the third 1,000 for the test.
Yeah, that's a good point.
Maybe it's not important, but I thought those sets had to be independent of each other. Otherwise, you could technically get a better fitting or better. What's the word?
Yeah, I think it's a good point, because I was also having some doubt when I was doing this, and then it's like actually in the exercise, like in the exercise document, there's a question. There's a question asks you how, like you need to motivate. How did you choose your? I mean, how did you get your training sets? I think you are. Yeah, I think. I mean, here what I'm doing here, like because it's possible, like for if I doing this way, like I was using 3 random perm like a command for those 3 data set, and of course it's gonna be possible that maybe there's a training set contains some index which is the same as in the validation set or in the test set, so that's possible. So yeah, I think your idea is making more sense. You just like draw random 3,000 and you just like divided them into like 1,000 each.
Into 3 then.
Yeah, that makes sense.
One thing I'll just add there as well, because you brought up that in the exam or the exercise, it asks you to, what does it actually say? To
which part you are referring? I have the document here.
It says motivate the choice of the data sets. I did ask them about that, but I didn't add it to that document you have because I don't know if I have the link for it. When the TA, or when they wrote that motivate the choice of the data sets, they mean as well as to what is each data set for? Like, what is the training set for? What is the validation set for? And what is the test set for? As well, yeah. You can kind of say why they, because if we're saying that they need to be different from each other, that's why you have to include that. But yeah, when he said motivate the choice of the data sets, because I had that same question, I was like, besides random, how else do you select this? And then he was like, no. What is each data set for?
Oh, that's so they are just wondering, did you know what they are doing? Like what these data sets are for? Okay.
Yeah.
So actually, I think I Googled it yesterday. I found something on Wikipedia or something, like what is the training set, validation set, and I think I found something here. But later on, I'm probably gonna add this. So what I'm gonna do later, I'm gonna share this page to I'm gonna kind of like summarize this and share these pages so you guys can have access. You can actually, or I think I already shared it. This page, check. Yeah, it's already public. So I don't know if you guys can just check this one. So chat. Cannot go. Okay, I just post this link on the chat, so maybe you guys can try it out. I don't know if it's gonna work. So I'm just gonna quick. Is it working?
Yeah.
Okay, I'm just gonna quickly move this to here.
Oh wait, maybe not. I only get the first page.
Same for me.
This one.
Yeah, I only get that page. Yeah.
Yeah, this is the page you are getting, right?
Yeah.
Yeah, that's. I already moved this question here, so you can see it, like the definition of training, validation, test. But these are just found in Wikipedia, so you need to restructure yours.
No, but I mean that it's literally only the first page that's coming up. None of the toggles work.
None of the toggle works.
Yeah, so like if I say open the first question I had about the choice of data set, or the other one, there, yeah, it does nothing.
You need to check what is the training
workshop.
Yeah, I think all those are empty. Just the third one, what is training, validation, and test.
Yeah, that's why I just like that's the last one is has some content, because the previous one is just like random stuff I were just just for putting there just to for testing. So, but later on we can add it. Okay? All right, I'm gonna just get rid of this. All right. So now we're talking about the we're still talking about how did you define your data sets. So I think we have some the one that you're seeing here. It's yeah, I think the idea of just like randomly select 3,000 and just like separate them each to 1,000. I think that's making a good point. And so let's move on to the second part, and which is trying to, oh, there's just one thing. So you need to, here they're asking you to show exactly the surface using this scatter interpolate and plot tree and the mesh. So this one, so I think the TA and like they already provide some answer to this. So it's just this code. So I will not explain. I mean, you can just have a look at this. So this is basically the template for drawing that surface, and then you just figure out. So you just need to figure out how to use it later on. Okay. So now.
May I ask where did this Q&A answers come from?
It's just a Google Doc. So yeah, I actually someone just shared it in the WhatsApp group. So.
I just copied them. Yeah.
Oh, is it from last year or?
No, it's from this year.
Right?
Last week.
Oh, okay.
Mm-hmm. All right. So for this one, you just need to actually, just figure out how it works, and so then you would finish your defining your training set, like those kind of data sets, and you just start to, train and train your feedback, train your network. So basically, actually, the most reference you can get is actually the algorithm 1 document, which is like they provided before. So I actually reuse most of the code from this algorithm 1, and it's basically, okay, first you need to do some configuration here. So you need to choose your algorithm, like which one training algorithm you want to use, and you choose your number of the neurons, and they are using this like approach things to run different kind of so that you are able to run different iteration on the data. So by iteration, I mean like if you're like this value is 1, then you just go through your training data set just once. Okay, and then if you're like 15, then 1,000, just like keep adding the iteration of learning. So if you so this is, I mean, I'm just talking totally based on totally basic on my based on my understanding, right? So if you say something, I'm just talking some bullshit, so just let me know. All right. So then you just like just go for like just create your network, and this is pretty standard here. So one thing, and here I found it's quite interesting that it's like you need to specify this parameter, which is a divide function, and then you need to say, okay, you're gonna use the divide string. So so I look it up in the document from MATLAB. So it's like if you are not doing this, so what they're gonna do, like defaultly, they're just gonna directly split your training data here, X train and T train. They're gonna just directly split it into 3 parts, okay? And then you just then they from that 1/3 part of the data set, they are doing training on that one. So here you need to specify this. Okay, you're gonna use all the we're gonna use all the training set here. So not instead of like divide by 3 and then just using one portion of it. Okay. And then you
Can
go
I
ahead.
say one thing?
Yes.
Yeah, I looked it up also, and normally in the case that we wouldn't have divided the sets, if we wouldn't have made the sets of 1000 yet, then in that case we would use a divide block, and then you can really specify what's the percentage you want to use for the training part, and then the validate part and test part. But I guess we're here using divide train because we already defined the size of train, validate, and test, right?
Mm-hmm. So
or
here,
am I seeing this wrong?
So for my understanding is that because in the exercise document, they clearly says that they want us to like divide it to 3 samples of 1000 points each for a data set. So so I think maybe we should follow this instruction. Or I think in practice you can do more kind of combination, like sometimes we just need to you can choose your percentage of your for different like for data set, training set, validation set, you can choose the proportion based on your practical application. But here I think that's a good thing to know actually.
Yeah, it makes sense. Yeah.
Is that true? We don't have to split the data into training data, validation data, or the test data. It can be split automatically if if I use the code you just show here, the configure net X chain and T chain. Have I made myself clear?
What I mean here, so you are saying like if we don't specify this divide string, then so if you don't specify this, they gonna just like. What is your question?
If I sorry, if I divide the divide FCN to the divide chain, so I don't have to split the data by myself. It is split automatically. Is that true?
Yes. So if you specify this divide train, it's gonna use all this X string as your training data.
Yeah.
But for your division, because we already have done this, we have already done this in the beginning. Like we already divide this training, like the whole data set into 3 training sets. So that's why here we want to use all the X training set for the training. But if you want, I think there is a cases that you just get your data set, okay, and then you just like if you want to do a quick analysis, then you just like it. You just directly use it, and they will divide it for you. I mean, then your training model
what's the
is gonna
percentage?
be what?
What's the percentage? For example,
that one I'm not so sure. I think anyone has an idea.
Yeah,
like if you
Yes, normally it was 70, 15, 15 if you just let it do the defaults.
Oh,
So 70% for training, 15 for validation, and 15 for test sets. So if you don't change anything, this is what you get.
So
okay.
70% training
But
and
in this
50%
specific
for...
example, if we take like 3,000 samples directly, then it should be
Yeah.
like 1/3, 1/3, 1/3, right?
Yes, like we do here in this example, it is indeed 1/3 because we divided it already before the actual creation of the network, if I understood correctly.
Yeah. Like how Simyao is doing it, we do not need to actually make any divisions.
Yeah.
Makes sense. Okay.
Okay. I'm just gonna put the remark here. So that's the is this a partition? So it's 70%. If you by default, it's 70% training and 50/50 for validation test, right?
Yeah.
Okay. All right.
And
So,
I will shortly post the codes what you can use if you have a divide block, if I find it back. So I will just post it when I find it.
yeah, no problem. Okay. So for this part, anyone still have question? The creation of the network. All right, let's move on. So now you're gonna train your network, okay? So I was basically just copy and paste to the one from the algorithm one. So in the algorithm one, if you know that they actually do it by a step and by step kind of like iteration, not an iteration, like, so they are increasing the iteration of your training. Okay, so for example, the first one, so they just trained once for one iteration. So this value like this in the configuration. So the first value is actually 1. So you just like first, this is the first training here. You just go through the data set once, and then then you just this is configuration for training, and then this is the actual training command, and you simulate it with your. And this is actually we're gonna talk about that later. Okay, this is just this is just talking about training. So you just train it once, and then of course you train it twice. You train it with your second step. So here is so the second one, delta epoch is the value of 14, and but here until here, if you execute this one, your network is actually trained for 15 times because previously you already trained once. Okay, so this is your network after one training, and this is the network after 15 times of training. So the same here. If then later step because here I put the 85. So this is actually, so the final one is like the training network after 100. So this last step, but you can manipulate of this delta push array or list. I don't know how to, you can change this value just to play around, like you want to see the result, your network result after how many times of this iterations. So so that's basically how my understanding so far. So any comments, feedback?
I understood it the same way actually. So until here, yes.
All right. Okay, so then and this part is basically those block. Those block is basically the simulation after within your, like, so you already obtain your model, right? So you already obtain your model, and what I was doing here is basically just using this model, just simulate the results using the test set, validation test, and the training set as well. So I will explain later why why I'm doing this. So here you get your, so basically this step you finish your training of the network, and I was getting, and I'm getting some like result from this network using this input data from the training validation test. Okay. So now actually comes quite a good question, actually, because in the beginning I was wondering what is this validation? How did you, because here, like in this here, you need to build and train your feed-forward network using both the training set and validation set. Okay, so as you know, as most of you should know that like the training set is basically just using it to obtain your network, right? So that's basically how it is. And the validation set is kind of like you actually compare, you using the validation set kind of like to further tune. So if so now I need to go back to this what I found in Wikipedia about training set, a validation set here. So after you get your training set, and then this model you've generated from your training set is to predict the response for the observation in the second data set, which is the validation set. The validation set provides unbiased evaluation of your training model and using a training. And this is, so when you are using this, this is to turn the model's hyperparameters, like the number of the hidden units, like and the layer length. So basically, for example, here, maybe you can use it to fine tune. You can use this tune the number of the neurons in the layer. So you can try use it, and also it can be used as the regularization by early stopping. So, like I said here in this code, because you can try different kind of like a number of iteration, right? So by regulation, so this is when I go back to the lectures and I was finding what is this about regularization. So there's a graph I want to show. I don't know where I have it. So there's a graph from the lecture saying that, let me check about this training network. So there's a graph here. Not this one, sorry. Okay, so here, where is that graph? Okay. Okay, so this is a graph I was talking about. So early stopping as a regularization. So here, what I understanding from this graph, so you are training so you are using both your training sets, right, to train your models, and you are training with different. You can train the model like for a number of times, like which is like for the code here, like you can choose how many times you use the data to iterate your data, and then at some point, this is like the horizontal. So horizontal is the iteration step, and the vertical one is your error rate, or for both your training set and the validation set. So here you need to stop here, right? So when you find out, because I mean here, when your arrow goes down, then it means that your accuracy of your model is going up. And here, so you need to choose the iteration points where, for the validation, the accuracy is actually, the arrow is actually going up again. So you need to find the optimal. I was thinking that you need to find the optimal iteration step here. So you need to find the value. So if we go back to the code here, go back to the code. we go back to the code here. So what I mean, so what I understand is that, okay, so what you're gonna do is basically you need to calculate your arrows for your for training set, both your training set and your validation set after you obtain the model. So that's why when I was training model, I directly calculate what is like what is the output for using this model and for the input of the training set and validation set. So then in a validation, I just say, okay, I just gonna calculate it all these for arrows, like the mean square arrows for both both the validation and also the training set. And then I'm gonna just like a plot them. So I want to obtain the similar graph which I was saying before in the lecture, and I want to find the one find the part, find the distribution step which is actually we are seeing that's a kind of a rise of this of the rise of the arrow from the validation set. So that's why I was basically trying to do here. I'm trying to plot a graph and to find out okay which iteration step is in which iteration step the arrow is for the validation is going up again. Okay. And
Were
of
you
course,
able to find it?
So I need to quickly run my code. So I think I found something between. I found something in the. So I think I found something like between 15 times of the iteration. So let me just quickly run this code. Yeah? Okay, I need to change my directory.
You can just do add to path, it will work.
Sorry, I'm not so good at this of this MATLAB things now. Okay, let's just run this. So here I was using this algorithm, training algorithm. So add to the path, right? You are saying.
Yeah. Yes.
Okay. So this is just doing something. Some graph. So I was getting so again the horizontal one is the iteration and this one is the arrow, right? And the blue one is a training set. So you are finding training set. So it's basically just gonna drop and drop like 15 here. Which is maximum, but I don't know whether here is.
Why the validation?
So the validation is this orange line. So it's also here, but I don't know if it's.
Why the model fit the validation set better than the training set?
Yeah, I don't think it's supposed to.
Yeah, that's true. That's good. That's a good point. But actually, you see that in the beginning here. Yeah.
With the validation set. Okay. So with the training set, the iterations is basically it's basically using the data over and over again to train its model. With the validation set, is it the same thing that you're doing train with the validation, or how is it?
I don't think so. I think we are just using the training set to generate the model. So validation set is basically, once I have my model, then I just use this validation set to calculate. So I put the input of the validation set to get the output from the model, right? And then I use these values just to compare it with the target value of the validation set, and I just calculate the arrows basically. I'm not training on validation.
But what are the iterations then? What are the iterations across the different validation set? Is that just is that for each? Let me think now. Yeah, no, what are the iterations then on the validation set? Is it the same iteration? So basically that your training set does creates a model after one iteration, and then you're using your validation set to compare, and then it continues. So it's only the training set that changes the model. But your validation set's supposed to change your model.
Well, that's why. So because I was getting, so from my understanding, is like you are only getting your models from your training set, right? Like you are not gonna use the validation or test model to actually. You can use it for comparison, for evaluation, you don't use it for, again, training your data set, training your model, right?
Yeah, indeed.
But I thought you were supposed to use the validation set to change the hyperparameters, no?
Yeah. For example,
hyperparameter.
So you can use that the performance, basically using your performance, your validation set. So you can experiment, like I said, you can experiment with your number of the iteration that you are trying to do, or the training, or you can change here like this number of narrow. So if you change, if here is 50, you can change it to whatever value just to find out which number of the narrow and give you the best result, I guess. And then that's basically, it's how it works.
Right,
I think how it works.
Okay, but basically the graph you were showing there before was basically on each iteration of your training data changing your model, you then also use that model with your validation set and basically compared the two.
Yeah.
Okay. So your validation set, it just gets used on each iteration repeatedly to see how the model is improved.
Yeah.
Okay, no, that makes sense.
Yeah, so I think here there's also operation. So people are asking like why your somehow your validation set is actually getting less error. But here you can see that in the beginning it's actually has, first iteration it has a bigger error than the training set. I think that makes kind of sense now. But I'm not sure if it's that always gonna be the case. Maybe. Yeah, I mean it's not. I don't think it's like if even it's possible that your validation set your model from your training set can do better prediction, like it's having less error in your validation set, because
but I think as your iterations go on though, if you're only using your training set, your model will end up overfitting just to that training set. So your validation error should go, that's why your validation error should go back up again, is because the model overfits the training data.
Yeah.
Which is then,
we can do this quite quickly here. So I was doing here, like I was doing the iteration from basically 1 to 100, right? So I think in the beginning it's like 1000 or something. So maybe I can just increase this number up. So this is the one you go with 1000. So in the end you will train 1000 times. So let's see how it works.
Can we say that if the error on the validation set is better than the training set, then the model is worse than a random
generator
model? Yeah, random generator.
Anyone wants to respond to that?
I think it's not wrong that it's better on the validation set. Like it's not generally seen, but I don't think it has something, it says that something is wrong with the model.
No, but I think your error should go back up again.
Was like, it's just randomly selected, right? In this case. I don't see the problem actually here. It could be better.
Your error should go up again on the validation set as the iterations increase, no? Because as the iterations increase, your model overfits on the training data. So then there's no way that your validation data could be better because it's so finely tuned to the training data.
I think even the training loss or that training error does not change at all. I mean, I think like after some iterations, like after 10 iterations, it thinks it has reached that local minima or global minima, whatever, and it does not take any steps at all. And the function which it learned, it does not change. Like after 15 iteration till 1000 iteration, the function that has learned, it has stayed constant. That is what I interpret from this graph. And that is why the validation error also does not change at all. Because we assume that as we are doing more epochs, it's learning a different function at every step. It's estimating a new function, but maybe they stopped estimating because it reached the global minima.
I was also
think it's supposed to stop.
Because the error is not 0. But yeah, that's how I interpret it.
I have one additional question actually, and that is we used 50 hidden layers, and maybe that is the reason that this is happening. I was wondering, for example, if you would use only 2, then I think we may get a different result, and actually seeing that the difference between the training and validation set is actually changing. It is, I didn't try it out yet, but I had something like 12 in the hidden layers, and I still wanted to tune it and try different stuff.
Yeah. It makes sense for you, and it's even worse now. Oh my god, the difference is even worse. No, but it's not more, just that the scale of the graph is different now. Earlier it used to be like it's from 0.65 to 0.15 in the y-axis.
Yeah,
it's just the scale is different.
Yes, scale is different now because I'm just using 2 narrow, so definitely the arrow is gonna go up pretty fast. So let's try 20. Yeah, now it's decreased a bit. So now the scale is
I feel it is unnatural to see something like this, but it's not wrong in my opinion. But yeah, I mean, if anyone has a different explanation, I'm of course open to it.
Well, another thing I was thinking here is like can be improved here, because here I just trained, like I just select like 3 step of the training, right? So the one, because I think you can extend this code, like you can just if you want to see more, graph, like a graph out of it, so you can just change the, how do you say this one? So you change the delta input here, so you can maybe add some more values so that and you can see more data points. But the thing is, I'm observing is that, as you guys also, I think you already see it here, it's like, it seems like even after, let's say I've choose some kind of like configuration. So I have my fixed narrow, a number of narrows, and I have fixed number of the, the number of the narrow is the same. So here, if you see, I mean, so this is a result of like just 15 times of iteration, right? And this is also after 1000, and it seems they are exactly the same, right? So then I just realized, I was just wondering, is it just because the function cannot be improved anymore after a certain iteration, or yeah? So
I think it's worthwhile to check a different algorithm and see how it performs here. Instead of what, I don't know what you're using right now.
This one is using the BFG, so BFGS. So maybe if I choose the basic one, the gradient descent, maybe we can see some more funny results.
Actually, with I think 2 or 3 algorithms. So in the former exercise, we already saw that we got a plateau after 15 iterations. It didn't improve anymore. And this is also what we are seeing here.
Yeah.
Yeah. Here, so now I already changed it to the gradient descent algorithm. So yeah, it seems to be the same situation.
Still the same, I guess.
So I think that's maybe the one of the secret they want us to find out, huh?
Yeah.
Maybe that's one of the points, because that's why they choose this number, huh? All right. So where are we? So then it's just like you need to, what else on this requirement? And compare the mean square on the test set. So later on, so what I did before is like I just calculate the mean square rate for the training set and the validation sets just to find out the optimal hyperparameters. And then in the end, you want to calculate this, like, of course, you want to calculate the error on the test set as well. So for me, I just directly, I think I just directly calculate it, and I just directly post it on the graph.
I have a question. How do you select the number of the layers and the number of neurons each layer? Because there might be a lot of choices.
Well, for that one, it's like then you need to experiment with when you're comparing your results. Like I said, you need to compare your results with your validation set and training set. So you see which kind of like configuration gives you the best result. Then this is the one you have to experiment. But actually here I have a question. So here, this H here is just number of the neurons in the hidden layer, right? So I'm not sure how did you configure the numbers of layer. Is there any things, because I haven't checked that. So anyone want to comment?
Well, yeah, it has a lot to do with the complexity, and I actually found out two things about it. One was that for example, let me think. There was a person on internet saying that when you look at the surface and you look at the amount of local minima, that sometimes can reflect the amount of hidden layers you need. That is one thing. But then the other thing, the function that we need to use is quite simple. So it might even be that we need 0 hidden layers.
Oh, yeah, but I think that's good to know. But my question is there? Because during this coding, during this programming, I actually don't see anywhere. I don't know. I was assuming that those kind of network is just, I don't know which parameters actually you can use to configure the number of layers. I mean, here H here is just like number of the neurons, right? So
okay.
But is it by default, like if you are training like this, then you are, I don't know, it's just like 2 layer, or I'm not sure how many layers we had for this network.
I think, but I might be wrong, it's the transfer functions, no?
How to make it like more layers in the hidden layer, I think you want that.
Yeah, so, but let's say for this one, for this code example, do you know how many layers for this network?
This is just 1 layer, but I put this 1 line of code in chat. If you see, it's like a 3-layer neural network now.
Wait, chat.
It's just adding more H in a square bracket like that.
Why I'm not seeing your chat? Oh, you just
show
like
your
this?
code.
Yes. It's just like this is a 3-layer neural network with 20 each, like that. You could put a different number everywhere, like H1, H2, H3, and have different number of neurons in every layer. But this is basically how you do it, create more hidden layers.
Okay.
Genius.
Okay, so if I don't do it, it's just like one layer, right?
Yes.
Okay.
So
Easy.
hence your code here is defining a 3-layer. Is it a 3-layer network?
Yeah.
It's 3 hidden layer network, yeah. You've
3
got
hidden
3
layer.
yeah.
3 hidden layer. Yeah.
Okay, here it says you need to select a suitable level, so you need to configure the number of layers and also the number of neurons in each hidden layer. And so yeah, so this one, so like with this, like I suggested before, so so you need to take a look at the surface of the which surface is it? Is it the surface of your training result, or what kind of service you are talking about? Is that Annie is saying that, or who said that?
It was me. I just was reading something about it. I think it was on the surface of the training set.
Training set.
Is it
So
a
you
3D?
basic surface
But
or training set?
that was just a remark of something on internet.
Okay.
And
Okay.
I hope I'm just not being wrong about it. I think it might be good. We may test it, but it is not a golden standard or something.
Yeah.
But this person found out that approximately the number of hidden layers would be a bit around the amount of local minima, but it's for myself, I can't say that I understand it well enough to say that I'm really sure and that it should be like that.
Yeah, that's good. That's fine. I mean, well, eventually we're gonna study the lecture and theory much deeper and also do some more trial, also try out to see. But I think if I remember this, it's like if you kind of English, it's like you want to also for like a time complexity, you want to find actually a model which can have a decent amount of accuracy, but also not so how do you say, not so like complex. I think this is mentioned in the lecture, like there's a complexity of something, right, over a model. Like you want to because that one in the end, if you have a very complex model, and then it's gonna take a lot of times to use it afterwards, like to predict or something. But this one I think we can drop this topic now, and then I think it's the job for later when you study again, like you study the theory again, and then you figure out, okay, what is the reasonable explanation for this. But we will if so this question we will leave it open, and then if you we will probably gonna post it into the WhatsApp group and just to leave it open and let people try to share their opinion.
Yeah.
Right. Okay. So for this coding part, so then you at the end they ask you to just just give you. So when you think your training network is perfect, then you just you just calculate the error on the test set and comment on the result, comparing with training. Comment on the result and compare with the training performance. What else could you do to improve the? Well, this is an open question, so yeah. And compare with the training performance.
I have a question here. As for the F1 to F5, do we have to care about what are they? Because it declares that 5 existing nonlinear functions F1 to F5, do we have to care about it?
I don't really care, right? That's just a function. You are basically you are providing a data set of those functions, of this like values based on those functions. I don't really think you need to really care about this.
Yeah, I think so, because we have already get the T1 to T5.
Yeah, once you get your T new, so basically you are just training a network which takes the input X of X1, X2, and then you just want to get some values to to approximate this T new, like the output, right? So then you don't have to worry about what is F1, F2 looks like, I guess.
Yeah.
All right. Okay. So I think that's pretty much about this performance, how do you say, personal regression example. So, well, I think we discussed a lot, and there are still open questions though, but I think we can keep on working on it in the WhatsApp group. And here, so yeah, more questions coming up. If not,
I think the next part is
share
like
the Google Doc
experimentation, and when we do more things, we can find out. Yeah.
Yeah. So we can pass this one. I mean, right now, anyone still have some maybe question about how did you how to any like procedure not clear about how to implement what the I think we're gonna so later on you can find this so in this web link I was sharing here. So later on, I think you can just go to the code breakdown and just to find the example of like how the breakdown structure of this code, and you can modify it with your own needs. And then if you still have question about how implementing the code, you just need then you can ask it in the group. Okay.
Yeah, what's this the page on the right? Is there a link for it? The ANN workshop.
Yeah, there's a link. There's a link. I don't know if you see it. It's actually.
Could you send it?
It's on the chat, right? It's in the chat of this.
And also for the Google Doc, can you please share it here?
Yeah. I can see that.
Okay, maybe I just directly post it in the WhatsApp group again, just to because people don't have to. The people who don't attend this session, then they need to ask me again and again. All right.
Who are maintaining this workshop? This code breakdown.
Okay, I already just post on the link, the Google Doc, and also this web link, also this web page in the WhatsApp, so you guys can find me there.
Thanks, man. That's really helpful.
Thanks, Neil.
Yeah.
Well, yeah. I mean, this semester is tough for everyone. So, this coding part, I think for some people are choosing this course, they are not so good at coding, so they might just stuck at somewhere just for a long period of time. Yeah. And we don't have to submit our codes so that they cannot check they will not check you are using the same code or not. So I think it's fine. It's more important about how you actually learn those theory and understand instead of coding.
Yeah.
All right.
I hope everyone is struggling with the math involved in this course, and it's just not me.
All right. Let's keep going for. So this one we're just gonna call it a break here. for this one. So he actually, the last one is kind of like, well, if I talk about how did you actually do the experiment with the last exercise, I think you can just directly use that algorithm one code, and you just, and this is like train BR is just one of the training models, a training algorithm you can just choose. So basically what I mean is that you just go to your algorithm one, and you just, because here it's already comparing two algorithms, right? So you basically just actually just type this train BR and this Bayesian regularization propagation, and then you just it's actually, I think it's exactly the same task. It's like now they introduce one more, and then you need to dig into more why it's behaving like that. So I'm not gonna talk about this. This is like this. You guys, if you're interested, you can read this through all of this. This fancy words. But I read. Yeah, I mean, but for if you are just talking about this exercise, how do you do it? It's just like, okay, you just need to use this train bar as one of your learning algorithm, and you just, because it's same thing, like you are using the same function, and you are comparing with the noisy data also, and then you just compare with other algorithms which has been investigated before. So you just compare the test errors and consider this network many errors. Do you see any improvement? So yeah, I think it's just you don't have to code more things for this exercise. You just need to change your parameter or change that algorithm, training algorithm, and the name and some parameter if there is any parameters. So yeah, I think that's basically it for this for the second part, for this part, I mean, for the 5 exercise here. Okay. Any question? Any comments on this?
No, man. I think it's super helpful. Yeah, thank you so much.
How does how do these exercises relate to the Bayesian stuff that just came before it?
To be honest, I have no idea. But it seems like it's just something new. Like, because what I read about this, I mean, it's basically a lot of background. They are trying to introduce this kind of oh, my internet connection. So they are trying to just building up some paths that you can actually introduce this new learning method.
Yeah,
And
yeah.
then,
But there's the train BR thing is there as well.
Yeah, they're just trying to introduce you to this new training method, I guess. And then you just, but for the exercise itself, you just need to compare with others. And of course, I think in the end, if you need to really understand what is this going on here, and then you just, and then, but now, for now, I think for the exercise, if you just want to get some results, you just, just do it. Yeah.
Is everyone like planning to write the report right now, or wait later in the course to understand more things and then write the report? Actually, what's your strategy here? I'm just interested.
I'm waiting.
Well, yeah, for me, I was just like, okay, I need to get the code working, right? You want to get the code working, and you try to collect results later on for a report as much as possible. And then, because what I heard is that because so for this course, there's no actually written exam, right? It's just gonna be your report and your discussion with your professor online for like 10 or 15 minutes. I don't know.
Yeah, so, it's a 10-minute oral exam, so just speak very, very slowly when you answer the question.
So but that's why you have to actually during your study, because this course is gonna end in the middle of the next month, right? If I understand, because later on they're gonna start with the sport vector machine again, and so after this course, it's gonna be in the next month, in the middle of next month, this course is just gonna end, and then it's like then I mean, well, you can spend. I think it's a good idea to just spend much time on this as much as possible. You can start to writing some report, and then but That's why we are studying this group, so that when you are writing a report, if there's some question, like when you, and then you're gonna be like, then you can directly post in a group and see everybody's having some other opinion on this. So, but because in the end, because I don't know how many people are doing the thesis this year, so by the end of the April and the May, you're gonna be, if you are doing a thesis, then it's gonna be super like intense, because in the end you want to, you know, like you want to really like work on your thesis full time, right? So it's better to finish. I would suggest to just try to finish the work as much as possible before the exam, and then when you finally, when you prepare the exam, you just need to, you know, go through the slide and then just go through a report, you know, and then yeah. I think
makes sense.
that's my I would take that approach if I was thinking.
Okay. Yeah. Thanks.
All right.
Shall we do this regularly?
Yeah, sure. Next time I'm gonna bring some beer because I'm thirsty now.
No bad.
Good to talk about while being a bit tipsy.
Yeah. So anyone still have any question? And then we're gonna call it a date here, and then tomorrow we're gonna see each other in the lecture again.
Yep.
Yeah, sounds good.
Come on, people, last chance.
Thank you so much.
All right, it's good to see you. I mean, for me, it's like it's okay. I mean, I think it's a good motivation for me to study, and also to do this. And also, I enjoyed this. It feels like doing a podcast, and yeah. So just one comfort, huh? So later on, I'm gonna, because we are recording this, I'm gonna stop recording right now, just to be sure. So recording on this.